can't emphasize this enough. Save this video and the rest of the videos that I've done on integrating algebraic fractions, because even if you've not seen them in class yet, you're going to see these kind of integration questions soon. So save them. This is video 6 in my series. We're going to look at integrating an algebraic fraction. We have a quadratic on the top and also a quadratic on the bottom. So as a reminder, we've done this type of integral, this one, this one, this one, this one. Today, we're going to look at something like this. So let's go through an example. So this is going to be our example today. Now, we talked about something similar to this when we looked at these two examples from video 2 and video 3. When the order of your polynomial on the top of your fraction is equal to the order on the bottom or bigger than the order on the bottom, so in this case, the order on the top is 2, the biggest power you see is 2, the biggest power of x is 2, and the same on the bottom, the order is 2, you have to do long division first. So again, because the order of the numerator is bigger than or equal to the order of the denominator, step 1, algebraic long division. We've got our bus stop like this. We're going to do 3x squared divided by x squared. That is going to be 3. So going to put a 3 up there. And then we're going to do 3 multiplied by our divisor. So 3 times x squared is 3x squared. 3 times 3x, that's going to be 9x, so plus 9x. And then 3 times 10 is 30. And then do row 1, take away row 2. So that's going to give us 0 for the x squared terms. 3x take away 9x is minus 6x. And 21 take away 30 is minus 9. So this there is our remainder. The quotient is 3. So therefore what we know is we know that this thing is going to be 3 and then plus this value over the divisor. So this thing is 3, that's equal to 3, and then plus the remainder, minus 6x minus 9, all divided by that there. So x squared plus 3x plus 10. So what we're trying to do with this question is we're trying to integrate this there. So we're literally just integrating that with respect to x, and we're integrating this all with respect to x. So we're trying to calculate this. Now we can just split this up into 2 separate integrals. So just split that up like so. And in fact, what I'm going to do, because do you notice how both of these values there are negative? I'm going to factorize out a minus sign to the front here. So now we get something like this where both these terms become positive. So now integrating 3 is pretty straightforward. This is year 12 maths, integrating 3 with respect to x. That is going to be 3x. Now integrating this thing here, this is what we looked at yesterday in video 5. So if you're a bit stuck with what to do now, go back to video 5 in this series and you'll watch how we deal with things like this. Remember our algorithm that we followed. So the first step we need to do with a problem like this, we need to look at the bottom. Can we factorize it? That's the question. Now what we can do is go to the calculator, and when you go to the equation solver, A is 1, B is 3, C is 10, you try and solve that. No real roots. Okay, so we can't factorize it. If you could factorize it, what you would do is you'd factorize it, you'd split into partial fractions like what we did yesterday, and then you do a partial fraction calculation and integrate the partial fractions. Again, go back to yesterday's video if you need help with that. Because we can't do any factorization on the bottom, we have to use integration by substitution, and we need to let u be equal to the denominator. So we let u be equal to x squared plus 3x plus 10. So let u equal to that. So now remember what we do with integration by substitution is we differentiate this u so that we can try and remove this dx from the integral. So differentiate this, we get 2x plus 3. Sorry, that x there is horrendous. But what we can do now to try and work out a formula for dx, multiply both sides by dx, divide by 2x plus 3. We're going to get that du divided by 2x plus 3 is equal to dx. So now we can swap this instead of the dx there, and so what we get is something like this. So 3x minus integral 6x plus 9 divided by u, and then du over 2x plus 3 there. So now the trick is to notice how you can actually factorize out a 3 on the top. So factorize out a 3 on the top of this fraction there. And then now what you can do is just cancel out the 2x plus 3 there and there. So now we're left with integrating 3 over u with respect to u. Now hopefully if you've seen video 1, you'll be happy with this, that this is just going to be 3 because of the constant 3. And then integrating 1 over u, that is ln modulus of u and then plus c. So our final answer is going to be 3x and then minus 3 ln u, but u was this thing there. So it's going to be minus 3 ln modulus sines x squared plus 3x plus 10 and then plus c. Now, in fact, we don't really need the modulus signs here. I talked about this yesterday, but do let me know why you cannot, or why you can ignore the modulus signs in this case. There is a reason why you are allowed to do it with this specific case. So again, just let me know why I can do this. Well, if you did write the answer like this, that's fine. They're not going to take a mark off you for that. But I'm just saying you can write it like that if you wanted to. Now, I'm not going to do separate videos on these examples because the process is exactly the same as all of this. So the process when you have a cubic on the top or a quartic on the top or even more powers, the process is the same. You do long division first. You're going to end up with something like this, like with our previous example, and then you'll get a situation like this where you either factorize the bottom, like what we did yesterday, or you use substitution if you cannot factorize the bottom. So the process is exactly the same. It's just that the long division with these ones will be a little bit harder because there's going to be more steps with the long division, but the process is identical. So I'm not going to bother doing videos on these ones. So for tomorrow's video 7, I'm going to look at integrating something like this. So something where you have like a load of different x powers on the top, but you just have one term on the bottom, something times x to the power of something. That n there could be a whole number, it could be a minus number, it could be a fraction, doesn't really matter. We're going to look at what you would do if you get something looking like that. So you'll see that tomorrow, so get ready for that one.